Hi everyone, welcome to another episode of the Data Standard Audio Experience. On our show today, I have Kim Martin, a director of platform data science and engineering at Netflix. And today we're speaking about data in the public transportation space. So welcome to the show, Kim. I'm excited to speak more about the work that you're doing.
Thank you so much. It's an honor to be invited.
Yeah. Could you just go ahead and introduce yourself to our audience?
Sure. So howdy folks. I'm Kim Martin, tech evangelist and data enthusiast. I live in Austin, Texas after a tour of duty in New York City, which is my hometown, then the DC area, and then the San Francisco Bay Area. I am a graduate of Carnegie Mellon University, go Tartans, New York University, and the University of Massachusetts. I'm a mathematician and a computer scientist. I've worked in a number of different product domains throughout my career. I started my professional life working on streaming radio for HBO more than 2 decades ago. I also professionally worked on a robot and at a hedge fund and contributed to some secret government big data projects. I rewrote some travel search products, worked on YouTube Music, did some core Android things for Google, and now I work on optimizing Netflix's infrastructure. I'm also a tech advisor, a golfer, a single mother to a 7.5-month-old daughter, and a board gamer. And I'm excited we'll be able to talk about one of my passion areas today.
Yeah, that's awesome. And it's so great to hear all of the experiences that you've had because you've been able to work in a lot of different industries. And it's great to hear the differences of all of them that I'm sure that you've been able to experience, especially with working with data in all of these different industries. But today we're going to be specifically focusing on the public transportation area and your experiences from the projects that you worked on there. And so how is data being used in the public transportation space today?
Yeah, so the short answer is it's being misused in the space today. But I think the majority of public transportation authorities do a lot of basic data collection, like mainly for profit and loss type analysis, some scheduling analysis, some quality of service analysis, and sometimes for understanding the demand. But if you take public transport and you look at the schedules of like buses or trains or things like that, they don't change that frequently. So and the city around you is growing. So you probably know that they're not really investing that much into sort of the agility of that idea. So most of the work that's done is done manually and comes out of these transportation authorities in this annual report. And these annual reports done manually take around 10 to 11 months to actually compute. And so it's not just in the US that this happens, this is worldwide. So lots of global agencies do this quasi-manual activity of trying to distill recommendations of what equipment to buy, how much the system is costing, how much fares should be, et cetera. So some governments outsource their public transportation operations, the driving of buses and trains, the processing of fares, the counting of passengers, et cetera, to private vendors and their technology. But they don't put in place like really useful KPIs for the vendors. So the vendors like show up with trains or drivers or whatever, and that's like them meeting their contract, as opposed to things like the drivers or the buses need to be on time, 98% of the time or something like that. So most vendors are really only incentivized to get into the space and then keep that contract going, but not to outperform in the space. There's like very little keeping them honest. So when you wonder why it takes so long for public transport systems to improve, in large part, it's because there's very little oversight into how they operate. So as someone who grew up in New York City, I know plenty of people who are either don't have driver's licenses or don't use them, and they rely on public transportation to get to work and the grocery store and the doctor and the school and the beach and the park and everywhere else. And when they think about moving, they limit their options to only places that have good public transportation options. So the public transport game is in need of up-leveling, and cities are going to have to invest in making it a part of the story that attracts new residents who then pay taxes. And so you get where I'm going. So there's so much more that could be done if we were to tie the pieces of the story together between like equipment, operation, demand, fares, et cetera. And when you think about toll roads that have flexible pricing, that's like a step in that direction of really understanding the demand and trying to either drive the behavior or try to actually account for it, right? So you get more use of a road at a certain time. It costs more to take the toll roads that operate alongside of them or something like that. So data in in short, data is pretty manually used and there's very little oversight. And so there's a huge opportunity space.
Yeah, and that's very interesting to hear from your perspective that there's a lack of, or there isn't as much oversight right now. That's just really interesting. And can you tell us more about your experiences working with the data for swiping people into public transit? Since I know that you had mentioned this with me a bit offline before, but I'm sure our audience would like to hear more about your experiences here also.
Yeah, so as I talked to you before, a few years ago, I worked with a large company that's headquartered in San Diego. And what they do is they provide hardware machines for swiping passengers into transportation systems. Like if you think about New York and London and the Bay Area, they have these gates or these things that you swipe your Metro card into, or your Oyster card or your Clipper card into, and that gives you access to like the train system or the buses or whatever it is, whatever the transport module is. And you have that ticket, and that ticket or pass gets you on the system. In some areas, you have one that also gets you off. So you have to swipe off. I think in London, you have to swipe off. In the Bay Area, some places you have to swipe off and some you don't. New York, you don't have to swipe off at all. But so you have like a mix of open loop and closed loop systems where you're thinking about the ability to tell where people are coming in and going out of the transit system. So without going into too much detail, because I believe they're still working in the space, we wanted to be able to tell for places like Brisbane, Australia, and San Francisco what demand would be for various events like daily commutes, sporting events, holidays, transit strikes, and things like that in order to better service the transit systems. Like, would you add more train cars for the hours before, during, and after a baseball game if there were a train stop within walking distance of the ballpark? Probably, right? But, converging sort of the schedule of baseball games with the schedule of trains and the length of the trains and things like that are just things that the transport systems aren't doing easily. So my team and I developed some algorithms to try to understand people movement patterns and the coordination between trains, train lines, buses, etc. And I think what I learned the most in that experience is that having firsthand knowledge of the domain space adds a ton of value. So being from New York, I understood how people actually travel in New York. So I could get on one train and get off because the express came, and then bypass a bunch of like other local trains to get back on the local to actually get to my destination. And that's pretty normal behavior for people who live in cities. So I think that knowing a bit about the subject area or the domain area really does give you that extra either curiosity or that extra like incentive to innovate. And I think that at that time, all I had to rely on was like my knowledge in New York City and DC area. But as we were working with Brisbane and San Francisco and then eventually Dublin, Ireland, it was really difficult for me to understand how like the Bay Area transport systems worked without actually having gone out there. So I think, since I've lived in San Francisco and now I realize how much opportunity I left on the table, but ultimately trying to understand the demand and insert changes in the operations due to events that were predictable events. So baseball games, holidays, all those things was what we were tasked with. And it was really interesting.
Yeah, definitely. And it's such an interesting space to work in. And I can really hear the passion in your voice about this specific industry, since I'm sure there's a lot of different challenges that come up with problems that are interesting to solve every day in this field. So it's great to hear it from your perspective. What was your favorite part about working in this space?
Yeah, that's a really good question. So this work was done really early in the MapReduce and Hadoop days. So some of the algorithms we wanted to implement were simple things like single source shortest path on a graph, and realizing that you have to reimagine how you traverse a graph when you have this much data and want to run the algorithm millions of times in parallel was really fun and interesting. So we ended up doing some sort of like mix between breadth first and depth first search with the end limit, and ran that, kept adjusting our end to figure out when we had enough information. And in this case might have been like switches of a train. Like we introduced some heuristics about how often a person was likely to switch to get to their destination faster versus sit on a train and just let it ride. So that was really interesting and really fun to really try to dig into the psyche of people and incorporate that into your algorithms. Another thing, non-technical, that I really love loved about this space is actually something that I reflect on now. The idea that if we solve these types of problems and make public transportation more reliable, more available, more scalable, we can impact the behaviors of people. For instance, I would likely choose to not attend a baseball game if I knew that I would have to wait for long periods of time to get home because the schedule of the trains or the length of the trains meant that I'd be stuck at the baseball park for 30 minutes waiting on a train, right? Like these are solvable problems. We're just not yet invested in them. And I don't want to get political, but I do think that the nice thing about having Pete Buttigieg working on infrastructure problems is that he seems to be in touch with data solutions and the power of data. So I'm optimistic that the government can kick off some really great initiatives around scaling efficient public transport systems.
Yeah, definitely. My final question for you is just your take on the future of impact for the transportation space, and how do you think data will be changing the game for transportation in the next coming years?
Yeah, I think there's a huge opportunity here for drastic step function improvements in the transport space. It's extremely important that we think about these problems now as populations diversify. If you think about it, the public transport problem is a networking problem similar to that of computer networks. In computer networks, we worry about latency, availability, reliability, reachability, agility, among other things like security. In the public transport systems, if we broke down the problem in the same way, availability would be like, are there enough trains, buses, roads, et cetera, for the demand? And reliability would be like, are the trains, roads, buses there when you expect them to be there and can be used as intended? So think about how it felt the last time you got on a bus and it just broke down and you had to improvise your travel plans, right? So latency is like, how long are we waiting to use the trains, buses, roads, or either to get to the next use opportunity or to get to our destination? Reachability is like, how connected is this network? Can I take a train to a bus to my final destination? Are services like Uber and Lyft or even Lime scooters the next link in the reachability problem, right? Are they like the last 10% or the last mile or whatever? And then agility, how changeable is the transport network? If a baseball game or a fire or some event happens, can the system adjust to handle that event? And so I think that these computer and transport networks in the same way, except transport networks are much more expensive. So I'm not sure why it doesn't get as much attention. I guess the idea is that governments have endless supplies of money, but that money is actually called taxes. So maybe this problem is worth solving more than computer networking problems, which are more about profit margins.
Yeah, great insight there. And Kim, thanks so much for being on the show. It was so great to hear your perspective on everything from this space specifically. And we at the Data Standard, we're always trying to build a community where everyone can network and collaborate with other data experts. And what is something the community can help you do?
So I'm always hiring, and I'd love to meet more people who are interested in working on the hard problems of scale, reliability, and availability. And if anyone out there wants to start a transportation data practice, let's talk. I'm kidding.
That would be super cool to see, though. You and our community members putting that together. But yeah, if anyone's interested, reach out to Kim, please. And where can everyone reach out to find you online?
Yeah, you can definitely find me on LinkedIn, either at, /Kimberly Nicole Martin, or by searching Kim Martin Google or Kim Martin Netflix or Kim Martin Austin. Actually, I'm not sure about the last one, but the first two definitely turned me up.
Okay, perfect. And to our audience, for more information on the Data Standard, you can find us at www.datastandard.io, as well as on our LinkedIn and YouTube channel. And thank you so much, Kim, for joining us today. It was so great to have you on the show. It was such a pleasure to have you, so thank you.
You're welcome. It's my pleasure.